Okay, geometric sequences, right? So we're just moving ahead. Everything bumps up a day on the timeline, and then next Thursday becomes a review. Next Friday is the PD day or org day, whatever, and then the test will be on the Monday. Okay, so your test is a week from this coming Monday. Gives you lots of time, and we'll have a review class in there. Give you more time. So if I have a sequence 4, -20, +100, -500, what comes next? Positive 2,500. And what's after that? Negative 12,500. So you notice, what's -20 divided by 4? -5. What's 100 divided by -20? What's -500 divided by 100? -5. Okay, we got 20 over 3, 10 over 3, 5 over 6. What's next? 5 over 12. And what's next? 5 over 24. What are we doing each time? How are we getting the next term? Dividing by 2. I prefer to think of it as multiplying by a half, right? Just because if I've got a fraction and it's okay, multiply by 1/2, right, and that cancels here, giving you the 10. Multiply by a half, 10 is even, cancels, giving you the 3. Multiply by a half, okay, so the 5 gets multiplied by 1 and the 3 by 2, right? And then at this point we're just multiplying by a half, we're just changing the bottom. Since the top is no longer even, we can't reduce, right? We're just getting a smaller fraction. So a sequence is defined as geometric if the ratio between consecutive terms is constant. This constant is called the common ratio. Okay, so when you see an R in the formula, it's going to be a geometric sequence or series. When you see a D in the formula, it's an arithmetic sequence or series. Right? You'll get the formula sheet for the test, and at the top it will have them all, but it won't say arithmetic. I don't think it does. I'm going to take a look. I don't think it says arithmetic sequences in series and geometric sequences in series, because they don't do that for you in Math 30-1. No, it just says sequences and series, and then they're all laid out. But all the arithmetic are on the top line, and all the geometric are on the second line. So it makes it easy. They're all together. They're not jumbled, right? We're not going to jumble them up, but we're not going to tell you what they are. But the arithmetic are on the first line of formulas, the geometric on the second line. So you'll be able to distinguish which is which. So in terms of a geometric sequence, right? We got T1, T2, T3, T4, and so on. T1 is just T1. T2, we got to multiply by R. We take this T1R, multiply it by R, giving me T1R squared. Multiply that by R to get the next is TR cubed. Multiply that by R to get T1R to the 4th. What's T10 based on this pattern? R to the 9th. And what's T sub n? Okay, R to the n minus 1, right? So we can see the relationship between the subscripted number here and the exponent is that the exponent is 1 less than the term. Which term? We want term n, it's T1 times R to the n minus 1, right? Because T1 is just T1. You're not multiplying it by anything. Or if you like, you could say, well, I'm multiplying it by R to the 0 because anything to the power 0 is equal to 1. Okay, so general term for a geometric sequence is T sub n is equal to T1 times R to the power of n minus 1. And we got some examples to do. State the common ratio and the next two terms of the following geometric sequence. Now this isn't really obvious at first, right? It's not like going 2, 4, 8, 16, you can kind of see. So what we might want to do is like, all right, well, I know that R is equal to 150, any term divided by the preceding term, right? 150 over 180, which is 5 over 6, reduces to 5 over 6, right? Now your calculator could do that for you, right? Just go 150 divided by 180 and go math, enter, enter, and it'll change it into a fraction, and it'll give you a reduced fraction. Okay? And we'd rather have a fraction here than a decimal, right? Because decimals, I mean, 5/6 is a decimal, is a repeating decimal. It's like, well, where do you stop? Okay? You don't. You just use it as a fraction. Okay? So we'll go with 5/6. 150 times 5 over 6 gives us 125. 125 times 5 over 6 gives us 625 over 6. We like fractions because they're exact, right? We're not going to do decimals. If we say, you know, the 12th term rounded to the nearest 10th or 100th, then you do your rounding, right? And we're going to come up with, well, we've already got the formula, so we could figure that out. And what's the term after that? Because it'd be, yeah, 3125 over 36, right? I mean, nothing, 6 doesn't go into, see, 6 goes into 180, and 6 goes into 150. That's why we get just nice numbers, right? It's like 30 times 5. And R is, okay, we figured that out already, right? It's 5 over 6. Okay, and again, how do we get it? Well, 150 divided by 180, and also 125 divided by 150, right? Any term divided by the preceding term. And since the numbers are going down, we know that we're multiplying by a number that's less than 1, right? If it's bigger than 1, numbers go up, right? They're going to get bigger. If it's less than 1, you know, between 0 and 1, they get smaller. If it's negative, they flip signs, right? That's what we saw up here, right? 4, negative 20, positive 100, negative 500, positive 2500, right? So we got to watch for that. You know, if it's negative, then the signs will flip, okay, plus or minus. For the geometric sequence, 1600, 1200, 900, etc. State the equation for t sub n. So what I'm going to do, let's just list what we know here. So t1 is equal to, for this sequence, t1 is 1600, okay, that's easy. What's r equal to? So, yeah, we can't figure it out right away. We're going to have to calculate it. So we'll go 1200 divided by 1600, which is 0.75, but let's go with 3/4. You know, even though 0.75 is exact, right, I worry about the stuff with thirds and sixths, right? Because when you're dealing with thirds, it's, well, where do I stop? Well, you don't. Just put it in as 1/3 or 2/3. You know, with 1200 divided by 1600, that's a terminating decimal, right, 0.75. But I would still rather use 3/4. Okay. State the equation for t sub n. So t sub n is t1 times r to the n minus 1. When we're doing a general equation, right, we don't want a value for n. We want to have n in the equation. So really what we need is we need t1 and we need r. Okay, those are the two values that we're going to use. T sub n is just going to stay like that. So t1, 1600, and r is 3/4 to the n minus 1. So that's the general formula. If I want t20, you plug a 20 in for n. And you go 1600 times 3/4 to the 19, right? I mean 20 minus 1 or 19. Okay, which we don't want, we want t6. Okay, so t6 is 1600 3/4 to the 6 minus 1. I want to simplify that a little, so it's 1600 3/4 to the 5th. Okay, let me pull up my calculator, which I will get how. Let's go into here. Desktop. 83. Open up. Let's get the TI-83. Here we go. Close that. Okay, turn this on. Can't work off the board. So 1600 times, and let's put this in brackets. So I'm going to go bracket 3 divided by 4, close bracket, to the power of. Now, if you like, you could put bracket 6 minus 1 bracket, right? So you could just type this in. Just making sure you put brackets. But we've already worked it out, so let's just say 5. And we get 379.6875. 379.6875. It's 4 decimals. It ends there, though, so let's just leave it as the 4 decimals, right? Again, if we're asked numeric response or something, on this question, it would be rounded to the nearest whole number, because you can only fit 4 digits into a numeric response, right? And if there's a decimal, it has to be in the 2nd place or the 3rd place. So we couldn't do 379 point something, because that would fill the entire set of boxes. When you're filling a numeric response, where you start at the left, you go to the right, you leave blanks. So if the answer is 2, it's 2 blank, blank, blank. Okay. Now, I'm not going to mark you wrong if you go blank, blank, blank on the 2, but start getting in the habit of answering it the way that, because that's how Alberta Ed is going to be reading them when you're doing your diploma and stuff. So start left, go right, do any rounding. Determine which term is 492075 over 4096. Well, we could kind of keep going, but yeah, I don't really want to do that. So let's go with our formula. So T1 r to the n minus 1. We know T sub n, right? It's going to be this. This is the nth term we're trying to figure out n. So 492075 divided by 4096 is equal to 1600 times 3/4 to the n minus 1. So the unknown here is n. And then we have a little problem, which is we're solving for an unknown exponent, and we don't know how to do that. But we can use our calculator to do it for us. So we have 2 choices here. Choice number 1. Let me pull my calculator out. I'm going to go to y equals, down here, I'm going to go to y equals, and I'm going to type y1 as 492075 divided by 4096. And I'm going to hit enter. Okay, so I just want it, that's y1, my left-hand side. And y2, I'm going to type this in as 1600 times bracket 3 divided by 4 bracket, wait, need my 4 to the power of, and now I got to put this in brackets, right, x minus 1. And that all has to be in brackets. Okay? So the left side, 492075 over 4096. The right side, 1600 times 3/4 to the n minus 1. Now, what do I know about n? What kind of number is n? It's a natural number, right? Whole, it's not really whole. It can't be 0, but it's a natural number. So it's 1, 2, 3, 4, 5, 6, 7, 8, whatever. So I could graph this, right? But I don't want to. Instead, I'm going to go second function graph. I'm going to go into the table. So go second graph. You go into the table, and this is just 120.14, right? That's a constant. So what I'm going to look for is what value of x gives me a y2 value. When are these both 120.14? Right? So I'm just going to hit the down arrow, but not on there. I wonder if I could just, oh, look, I could just use the regular down arrow key. Okay, so I'm just looking, oh, there they are. Okay, so when x is 10, okay, which here is n is equal to 10, so it's the 10th term. The 10th term. Okay, now what we're finding is the x, right? It'll be 3/4 to the power of 9. You know, it's 1600 times 3/4 to the 9, but it gives me that. This is a 9 because it's 10 minus 1, but the n is here, right? So the x value you're finding is this x value, okay, or is this n value. So n is 10, it's the 10th term. Okay, if we go back to the calculator again, if you just look, because our first term should be 1600, right? Okay, and the 0th term doesn't mean anything. So there's your first term. You can see y2 is 1600. Okay, that's our first term. Then we got 1200, then we've got 900, right? So there's the series, 16, 12, 9, 16, T1, T2, T3. Okay, where did we find it? T10. Okay, and that's how we have to solve this. You could graph it. It's just a bit of a pain graphing, right, for two reasons. One is you got to adjust your window to be able to see this. We don't even know what this number is until we actually divide it out. Like, I really don't look at that. I can't say it's around 100 or something like that. You know, then we'd have to play with the window. If we go into the table, so we know it's one of the n values, right? One of these guys is exact. They'll be equal. That's all we got to find. Okay, questions on this page? Example 3. In a geometric sequence, T1 is 12 and T6 is 91.125. Determine the common ratio. Okay, what do we know? T1 is 12, T6 is 91.125. R is equal to, we don't know, that's what we're trying to find. And well, let's just use our formulas. You know, when it comes down to it, right, we're doing a geometric sequence. If you're not sure, how do I start this? What do I do? Just write out the formula. And say, oh, okay, well, we know T6. Let's put that in as T sub n, right? Which will make n equal to 6. So I can put a 6 here. And T1 is 12. So I know this, and I know this. That leaves me one unknown. Right? So this formula involves 4 quantities, T sub n, T1, R, and n. If we know 3 of them, we can solve for the 4th. So we'll go 91.125 is equal to 12 times R to the 6 minus 1. Okay, maybe throw a little dot in there, right? Say times. Okay, how are we going to solve this? Divide by 12. Okay, let's start off with that. So what's 91.125 divided by 12? Yeah, you can tell me because it's going to take too long. Or not.
It's 7.59375.
Okay. 7.59375 is equal to R to the 5. Okay, how do we get R? We fifth root. So you've got this number sitting there. You can just go second function, or you can do 5, you know, second root, 5 math, and then pick the xth root. Here, I'll show you. What do we have? So it was 91.125 divided by 12. Okay, so I can, whoops, I can go 5 math 5, which is the xth root, so I want the 5th root of, then go second function answer to bring that number in, and hit enter, and it's 1.5, which we can express as a fraction, right? Just go math, enter, enter, and 3 over 2. So R is equal to 3 over 2. Right. If you put 1.5, that's perfectly acceptable, right? It's a terminating decimal. Not a big deal. And this, they gave this as 91.125 and not as whatever 729 over 8 or something like that, right? So 1.5 would be acceptable. Let's what else is there? Photocopy. Yeah, okay, we'll do. Okay. A new car that costs $36,000 depreciates by 15% of its current value each year. Determine the value of the car after 6 years. Okay, so sometimes you may want to get a start on this and just sort of figure out, okay, so it's worth $36,000. How much is it worth the next year? What's the dollar value the next year? So figure it out, just give me a number. 30,600. Okay, agreed? Disagreed? All right, well, how do you get that? How do we go from 36,000 to 30,600? Why by 0.85? Because I thought it went down by 15%. Why not 15%? Yeah. So it went down by a dollar amount of $5,400, right? $5,400 is 15%. So if you did, oh, let's do 15% of 36,000, you get 5,400. Well, you know it's not worth $5,400 the second year, right? You know, oh, wait a minute, yeah. It doesn't go from 36,000 to 5,400. That's not a 15%. Then you're going to say, oh wait, it went down by 15%. So I have to subtract 5,400 from 36,000 to give me that. That's too much work. So what's the easier way? Well, the easier way is it goes down by 15%, so each year it's worth 85% of what it was. Okay? So each subsequent year, the car is worth 100% minus 15%, which is 85%, which is a decimal is 0.85. Okay? So when we depreciate, we're really interested in, but what's the value that's left? Okay? You walk into the store and you see something that says, sale, 40% off. So you say, oh, that's a $200 jacket. I can get 40% off. So you say, I'll save $80, which means I pay $120. Or you could say, if it's 40% off, it means I'm paying 60% of the price. And 60% of 200 is the 120. Okay? So you can go there directly, but when we depreciate, when we go down in value, depreciating by 15% means we're retaining 85% of the value. Okay, so that gives us a chance to say, so T1 is 36,000. My R value is 0.85. That's what I'm going to multiply by. We want it after 6 years. Okay, after 6 years, which term in the sequence is after 6 years?
6.
So is it T6 we're looking for? Okay, so it's a new car, 36,000. What's it worth after 1 year? Which term is that? T2. After 1 year, his term is T2. We're looking for T7, yeah. So this big thing with geometric sequences, especially when we're talking about values in years, right, is this is now, this is after 1 year. Okay? Now you might want to keep going and just do another one, 30, whatever it is, and then say that's after 2 years. So you can see, okay, this is T1, T2, and so after 6 years, is T7. Okay, so we're looking for T sub 7, right? And that means that n is equal to 7. Okay, so it often helps to write out a few years worth, right? So you just say, okay, now 1 year later, 2 years later. Okay, if I want 6 years later, after 6 years, right? And we got to read stuff. Is it after 6 years? Is it at the beginning of the 6th year? Stuff like that. And just sort of figure out what are they looking for? What are we trying to find? So we want T7, which is T1, 0.85 to the 7 minus 1. How much? Anyone? Well, 13,000. Okay, $13,577.38 is what this. Now, do cars depreciate like that? Is it 15% each year? No. What happens usually with cars? Yeah, so it's like you take a big loss in the first year, right? As soon as you drive it off the lot, this is a used car, right? So I don't know what you did to it. I don't know how you broke it in. So it's a used car, and it may go down by about 30%. Then after that, it slows down a bit. So we use this, but it's not really a model of what it may happen in the real world, but usually there's other factors that go into it. And part of that's mileage and condition and all of that stuff, right? Okay, but in the context of this question. So any questions? So a big thing to get at is, right, depreciates by 15% means there's 85% of the value left. A photocopier will only enlarge an image by 10%. Determine how many enlargements it will take for an image to be over twice its original size. So we don't have an exact value that we're looking for here, right? Like we don't know that we want 2.7 or something like that. We want it to be over twice its original size. So what are we going to start with? What's its original size going to be? What do you want to put for the original size? 1?
100.
Or 100?
1. 10.
Good. So the question becomes, do we want to work percents or do we want to work numbers? So 100% is 1, right? So if I go 100%, the next one would be 110%. If I go 1, the next one would be 1.1, right? Increasing by 10%. So any preference? 100, 110, or 1, 1.1? 100? Okay, so in this case, we're dealing with percent of the original size, right? 100%, 110%, multiply that by 10. Is that right? No, is that right? 110 times 10? Wait, do it. Or 110 times 1.1?
Yeah.
Yeah? Oh, that's right, because you multiply by 1.1. Okay, and what we want to find is some mysterious number which is greater than or equal to 200. Actually, it says over twice its original size, which means we really want to be greater than 200, which is going to be easy because it's never going to be exactly 200, so we're going to get some number and then it's going to hit and it'll be over 200. And we want to figure out, okay, how many enlargements, right? So T1, this is the original, which is T1. This is one enlargement, which is T2. This is two enlargements, which is T3. So if we find out that it's T10, how many enlargements will that be? Be 9 enlargements, right? Because we need to make a connection between this number and this number. Well, T2 is one enlargement, T3 is 2, T4 will be 3, T5 will be 4, T10 will be 9, and so on, right? Because our answer is going to be, you need this many enlargements, but we're going to end up saying it's the whatever term. Well, how many enlargements is that? It's one less than whatever term I am in, because the original term. Okay, so what do we know? We know that T1 is 100. What's R? 1.1. What would R be if we had used 1, 1.1, 1.21, and so on? What's R in this case? Also 1.1. Okay. So our R value doesn't matter what we started with, right? Start with 100% or we started with 1 and I want it to be greater than or equal to 2. The R value is 1.1. Okay, what's T sub n? We're going to go with 200, right? We're not going to find it. There won't be a value of n that makes that 200, right? But there will be a value that makes it bigger. Okay. But we need a starting point, so we're going to start with 200 there. Okay. I want it to be 200. Figure out what n is so I get 200. And this time I won't get an n value, right? Not like the last one with the 49075 over whatever, and it hit exactly on an n value. This won't. Okay, so let's plug in and see what we get. Formula, T sub n is T1 times R to the n minus 1. 200 is 100 times R, sorry, we know R, 1.1, to the n minus 1. Divide both sides by 100. Okay, so if we had started with 1, 1.1, 1.21, etc., we're going to end up at this line anyways, right? So by starting with 200, 100, we're going to divide out the 100 and end up with a 2. Okay. So it's just for convenience of your thinking, right? I like to think this is 100% and then 110% and so on, or it's size 1, then 1.1 and so on. Either way, leads to this. Okay, how are we going to solve this? Well, we're going to do the same thing we did before, right? We're going to go to the calculator. We're going to turn it on. we're going to go to y1, and we're going to put in 2. And we're going to go y2, and we're going to put in, whatever, 1.1. 1.1. And we'll delete a few things. 1.1 to the power of x minus 1. Don't need a bracket there, I guess. Okay, now I'm not going to graph. Again, I can go to the table. This time I don't expect to find a value. So I want to know, when is this equal to 2 or greater than 2? And there it is, right? When x is 9, we're over 2. When x is 8, we're at 194.87%, right? Multiplying by 100, change the percent. When x is 9, we are at 214%, which puts us over 200%, over twice its size. Okay, so we get n is equal to 9. So after how many enlargements?
8.
Okay, so after 8 enlargements, the image will be at least twice its size, right? Which I think what it's trying to say. Be over, well, be at least, be over, let's say over then. Be over, whoops. Will be over twice its original size. Okay, questions? Next. In a geometric sequence, T3 is 54 and T6 is negative, oh, that's the last one, okay. And T6 is negative 1458. Determine the values of T1 and R and state the values of the first 3 terms. Okay, so we got to get T1, T2, T3. Well, so really we got to get T1 and T2. We already have T3, so give me the first 3 terms. We already have the third one. In order to get T1, T2, we need to get T1 and R. That gives us how many unknowns? How many equations are we going to have? 2. Right? In order to solve for 2 unknowns, we need 2 equations. So, only formula we got is T sub n is equal to T1 times r to the n minus 1. We can fill in T3, right? So we could say 54 is equal to T1 times r to the what? Well, let's fill it in. 3 minus 1. So 54 is T1 times r squared. 1 equation. What's the other equation? Negative 1458 is equal to T1 times r to the 6 minus 1. Negative 1458 is equal to T1 times r to the 5th. Now there's a special way we're going to solve this system. And what it is, we're going to take one equation and divide it by the other equation. Okay. Because if we divide, what's T1 divided by T1? 1. So we'll get rid of the T1, right? So we're eliminating, but we do it by division. So I'm just going to rewrite it slightly different. T1 r to the 5th is negative 1458. T1 r squared is 54. Okay, let's say 1, 2. We're going to go number 1 divided by number 2. T1 r to the 5th divided by T1 r squared is r cubed. Negative 1458 divided by 54 is negative 27. So r is negative 3. Okay. Now, what's T1? Well, we go back to one of these original equations, right? So from here, we go T1 r squared is 54. T1 times negative 3 squared is 54. 9 times T1 is 54, and T1 is equal to 6. So it's 6 times negative 3 is negative 18 times negative 3 is positive 54. Okay, so we got T1, we got R, we got T1, T2, T3. Do one last one. So, okay, you want the short way? The short way is say, how do I get from T3 to T6? So I got T3. You multiply it by R, you get T4. Multiply it by R, you get T5. Multiply it by R, you get T6. Which means that 54R cubed is equal to negative 1458. And R cubed is equal to, right, and then so on. So that's kind of the short way, right? Is to say, well, how do you get from T3 to T6? You multiply by R to get 4, then 5, then 6. Multiply by R 3 times. Okay. Which means that 54R cubed is this, R cubed is this, and then R is negative 3. Okay, one last one, because there's something that's not on the sheet you got to say. So insert. Two, three, four, 6. Insert 5. Actually, you know what? Forget that. Insert 5 geometric means between 3 and negative 192. Let's do this, because we never did a means question. So insert 5 geometric means between 3 and negative 192. So what this means is you're going to start with 3, then you want to have 5 numbers. So 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, and then negative 192. So I need to make a geometric sequence that starts with 3 and has as its 7th term, right? So here we might want to write this down, right? This is T1, 2, 3, 4, 5, 6, and this is T7. Okay, and if you like, you can click T6, T5, T4, T3. So insert 5 geometric means. Make a sequence that starts with 3, ends with negative 192, has 5 terms in between them. Okay? And the sequence has to be geometric. So what we can say is, well, T sub n is T1 R to the n minus 1. We know T7, negative 192. We know that T1 is 3. And this will be R to the 7 minus 1, right? Because again, we know this is T7. So T7, we're using a 7. And it's R that we don't know, right? What's the common ratio? So negative 192 is equal to 3R to the 6th. Negative 64 is R to the 6th. What's R? Okay, sorry? No, you said. Go ahead. Negative 2 and? Positive 2. Yeah. Plus or minus 2. So the key to this, Ryan figured out, if it's an even power, then your root can be positive or your root can be negative. Okay? Keep in mind, what we're not doing here is this. I'm not saying, what's the 6th root of 64? If I say that, the answer is just 2. Okay. We're not saying that. We're saying something raised to the power of 6 is equal to negative, negative 64? No, hang on. No, you're right. I messed up. It's, forget this. Forget that's negative. Let's just make it positive. Do all that. Okay. Never mind. There we go. That'll work. Just erase all the negative signs you had. Danger of making stuff up on the spot. Wrong. So we're going 3, 192, right? So 64 is R to the 6th. R is plus or minus 2. It could be positive 2, could be negative 2. If it's positive 2, we're going to get 3, 12, 24, 48, 96, and 192, right? 1, 2, 3, we're going to get 3, 6, 12. So I got 1, 2, 3, 4, 5 geometric means. If r is negative 2, then the sequence goes 3, negative 6, positive 12, negative 24, positive 48, negative 96, positive 192. Okay? So basically, if your ratio is an even power, then the value of r is plus or minus the root, whatever root it is. So you'll get 2 possible sequences, you'll get 2 possible values for r. Okay, the one we did previously, it was odd, right? T3 to T6, you're multiplying by 3 r's. That's either positive or negative, right? An odd root is either positive or negative, but an even root is both positive and negative. Okay, so that's it for geometric sequences. All right, so the homework for geometric sequences as laid out in the textbook. If you have any questions from arithmetic series, ask those. Any questions from geometric sequences today, ask those. Monday we'll do geometric series. Tuesday, infinite geometric series. And start on the review if you like, but this will at least give some time. Wednesday we'll start trig. Thursday we'll review. Friday you're not here, and then Monday we'll test.